In exercise 1.5, we study that if we want to consider 3, 4 or 5 terms of an AP, we consider the following. Suppose if there are 3 consecutive terms in an AP, then we take the middlemost term as A, we take the previous term as A minus D, and we take the last term as A plus D. So the three consecutive terms of an AP are A minus D, A, and A plus D. In order to understand this, we say that let A be the center of these three terms. Then A minus D and A plus D are well placed around the center. So if A is on the line of symmetry, A minus D and A plus D are on the opposite sides of symmetry. So these are the three terms of an AP. But suppose if you want to consider 4 consecutive terms in an AP, then if we take A as the middlemost term, suppose if you take A as the middlemost term, then there would be a problem if you take A plus D as the, let's say, the second term or the third term, A minus D as the first term, and A plus 2D as the fourth term, there wouldn't be a particular symmetry. So in order to deal with this, we shall not take A as the center, but we shall take A minus D and A plus D as the middle two numbers, and then A minus 3D and A plus 3D as the first and the last numbers. So you can see that there is a difference of 2D between all these numbers. So they are well placed and they also follow the symmetry along A. So the four consecutive terms in an AP would be, the second term would be A minus D, the third term would be A plus D, the first term would be A minus 3D, and the last term, the fourth term, would be A plus 3D. This is a special case. And if there are 5 terms in an AP, then it wouldn't be a big problem. So we can take the middlemost number as A, then A minus D, then A plus D, then A minus 2D, and A plus 2D. So the 5 required numbers are the middlemost being A, the previous one being A minus D, the next is A plus D, the first one would be A minus 2D, while the last one would be A plus 2D. So these are the 5 consecutive terms in an AP. So let's take this example. Find 4 consecutive terms in an AP. So 4 consecutive terms in an AP, whose sum is 12, means the total is 12. Total of all the 4 numbers is 12. And the sum of the third and the fourth terms is 14. So we have been told that if you take, so we'll say let the 4 consecutive terms in an AP be, the second one would be A minus D, third one would be A plus D, the first one would be A minus 3D, remember, and the last one would be A plus 3D. This is the special case. So if you take the total of all these numbers, so you'll be getting A minus 3D plus A minus D plus A plus D plus A plus 3D, and the total is 12. So you can easily cancel out the 3D and the minus 3D, the plus D and the minus D. So you'll be getting A plus A plus A plus A, which is 4A, and that is equal to 12. So A is 12 over 4, which is equal to 3. So we got the A. Remember, A is not the first term, but A is one of the terms associated with D also in this particular sum. We do not consider A to be the first term. And the other information is the sum of the third and the fourth terms is 14. So the third term is this particular term and the fourth term is this term. So if you add the third and the fourth terms, you will get 14. So that means a plus d plus a plus 3d, the total is 14. So take the like terms together. A plus a is 2a plus d plus 3d is 4d is equal to 14. You can substitute the value of a is equal to 3 plus 4d is equal to 14. A is equal to 3 is from here. So 6 plus 4d is equal to 14. So 4d is equal to 14 minus 6. So 4d is equal to 8. Scroll it down further. Therefore d is equal to 8 upon 4, and therefore d is equal to 2. Now, in order to write the answer, we should be writing that the four terms or the four consecutive terms are: the first one is a minus 3d, the next one is a minus d, third one is a plus d, and the fourth one is a plus 3d. Now let us substitute. The value of a, if I am not wrong, is 3, and minus 3 into the value of d is 2. That is 3 minus 6, which is negative 3. Similarly, 3 minus 2, which is 1. Then we have 3 plus 2, which is equal to 5. And then the fourth number is 3 plus 3 into 2. The substitute, we will get that 3 plus 6, which is equal to 9. So if you see properly, the common difference is not actually 2 as we have expected, but it's actually 4. The common difference is 4, which is a double of 2 in this case, because a does not mean the first number and d does not actually mean the common difference when we take two terms. Let's take another example. Find the three consecutive terms in an AB whose sum is negative 3 and the product of their cubes is 512. So let the three consecutive terms in an AB, B will take the middle term as A, the last term is A plus D, and the first term is A minus D. So if you read it carefully, the sum of the three consecutive terms in an AB is negative 3, minus 3. So it means that if you write A minus D plus A plus A plus D, you get a minus 3. The beauty of this particular arrangement is that minus D and plus D easily cancel out. So we directly get the value of A. So A plus A is 3A is equal to minus 3. So A is equal to minus 3 upon 3, which is equal to minus 1. So remember, A is equal to minus 1 is the middle term and not the first one. And the product of their cubes is 512. So product means multiplication. So A minus D into A plus D. This is the product. But we have been told that product of their cubes, so we'll put the cubes also, is equal to 512. So we can write, since 512 is a perfect cube, we can write cube rooting both sides. So cube rooting both sides. Remember, you can only cube root both sides if there is a multiplication and not addition or subtraction. That would be illegal. So A minus D without the cube into A plus D is equal to, the cube root of 512 is 8. Now we can put the value of A as 1. A as minus 1 in fact. So minus 1 minus D into minus 1 into minus 1 plus D is equal to 8. Scroll it down. Now over here you can multiply this minus 1 to the first two terms of the first bracket. So that means minus 1 into minus 1 is 1, minus 1 into minus D is plus D, into 1 minus 1 plus D is equal to 8. Now I'll rewrite this 1 plus d as d plus 1, and I'll rewrite minus 1 plus d as d minus 1. I'm not changing the sign, I'm just rearranging it. Is equal to 8. Now why did I do so? Because it looks like a plus b into a minus b. So the formula is a square. So b square minus b square. So minus 1 square is equal to 8. Therefore d square minus 1 is equal to 8. We continue over here. Therefore d square is equal to 8 plus 1. Therefore d square is equal to 9. Square root in both sides, we get d is equal to plus or minus square root of 9. Remember to write plus or minus. It means that we have two answers. It could either be positive 3 or it could be a negative 3. So the first three terms are minus d, a and a plus d. So in order to find, we'll write a minus d, then a, and then a plus d. The value of a is minus 1. The value of d is 3. The first value of d is 3. The second value of d is minus 3. Since but we have a minus d over here, we'll take it as minus 3. So what is minus 1 minus 3? It's minus 4. Then we have a, we can directly write minus 1. And then we have a plus d. So we can write minus 1 plus 3, which is equal to 2. So remember, this is the particular case where we took a is equal to minus 1 and d is equal to 3. Now we'll have a particular case in which we'll take a is still minus 1 but d is negative 3. So in that particular case, a minus d would be minus 1 minus of minus 3, which is minus 1 plus 3, which is equal to 2. And then we have a, which is directly minus 1. And then we have a plus d, which is equal to minus 1 plus of minus 3, which is equal to minus 1 minus 3, which is equal to minus 4. So in either of the case, we get the same answer. The AP could be minus 4, minus 1 and 2, or 2, minus 1 and minus 4. Thanks for watching.